ASCII character, blah blah blah. Then this, let's say for capital S is hex number 51. So you need to be able to read this. Okay, any number we prefix with 0x is a hex number. So it's not 5, 1, it's actually 0, 1, 0, 1. We convert it to binary. And so you need to be able to convert this hex number into binary. Okay? And if they give you a decimal number, for example, then you should be able to convert it into binary as well. Okay? So basically, in a digital system, in real-time system, which is digital, we use mostly the microprocessor and computer. We handle with binary numbers. Okay. So topic 2 is, I think what you need to do is before you start, write a hex to binary table by yourself beside you. Okay, it's very handy. So you know how to write that. You know this is binary. And this is hex. That's it. So, first number is 0, 0, 0, 0. So, response to that. Then next is 0, 0, 0, 1. 0, 0, 1, 0. This is 1, this is 2. 0, 0, 1, 1. This is 3. And 0, 1, 0, 0. And then 0, 1, 0, 1. 0, 1, 0, 0, 1, 1, 1. 6, 7. 1, 0, 0, 0 is 8. So when you come to 10, it's no longer 10, right? It's 8. There's no 10, right? In hex number, it's 8. 1, B. 1, F. Right. So there's a very easy way to check whether you write the correct one. Look at 1, which is 0, 1, right? Look at 2. The second digit is 1. Look at 4. The third digit is 1. Look at 8. The fourth digit is 1. And of course, the last one, F, is 1, 1, 1, 1. Okay. And yeah. Okay. So with this table beside, and with 1 minute in this case. So this is topic 2. Topic 3. So there are 2 things you need to practice. First is the addressing mode. Look at the first level of that formula. So there are pre-index addressing mode and post-index addressing mode. What's the difference? And in pre-index addressing mode, basically A, B, C are pre-indexed, right? D and E are post-indexed. The difference is how you place the square bracket. So if you put the square bracket for the last 2 options, then it's pre-indexed. If you put the square bracket for the middle one, then it's post-indexed. And there are in pre-index, there are 2 kinds. One is with exclamation mark and without. Okay. So if without, then you don't have to update the address. And with the exclamation mark, you have to update the address. Okay. So this is the difference. If I give you some register, and their addresses and contents in the address, you should be able to know. Okay, so anything with bracket means the content in the, for example, so this one. If you look at R0 itself, okay, let's say R1, okay, the things that, if you put a bracket, B, okay, if you put bracket on a register, that means the content, okay, and how to look for the content, you know the address. So R1 actually store the address, and the content has to be loaded into another register R1. Okay, so the address of a register and the content of a register is different. So like you have a home address, and who stays in your home address is your family, right? So that's the content. And the dot hex number, phone number, that is the address. Okay. So if you put a bracket on your address, as a dot 112, unit 15, 12, that is the address. Okay, and if you put a bracket over it, it becomes your family. Who stays in the address is the content. And when you update the address. Okay. And the next one is question 3 in the part 2 of that tutorial. This question, remember? So you need to know, for example, ADD is for addition. If you put ADDS, that means in addition to do the addition, this instruction will also update the condition flag, okay? And Z, C, and D. A means negative, Z means the result is 0, C means a carry, D means overflow. And you probably need to use this condition flag when there is an instruction with a condition check appears. For example, for this S, okay, when the computer execute this instruction, then you will write the condition flag. And until the fifth one is the condition flag will be checked. Okay. And what does EQ mean? EQ means you will check whether the 0 flag is 1, right? And this table will be given in the appendix to your example. You need to memorize this. What you need to know is you need to find out EQ, and you need to know it has to be the Z bit will be checked. Okay. So for this particular example, the result is not 0, right? So the Z bit will not be checked. So when you execute to the fifth instruction, AEQ, when the system checks EQ whether it is set, if it's not set, and in this case it is not set, so this instruction will not be executed. So you can just ignore this instruction. So of course the data in the register will not be updated accordingly. So that's the thing. And all the loading, you need to be careful about whether it is loading of words, loading of bytes, or loading password, so on and so forth. Okay. Basically, the most common one is to know by default LDR without anything is to know the word, which is 32 bits. LDRB is know the byte, means 1 byte is 8 bits. It's just one word.
Ya, cambia. Vamos a arrancar. Ya tenemos un poquito de
And another thing is there are some instructions which will set the function bit by default, for example, compare. Okay, so it doesn't need to add s after the instruction. So it will just set the function bit by default. So later on, when there is a instruction which needs to check the function set, and you should know, that. Usually for addition, subtraction, and move, for example, these won't set the function flag if there is no s postfix. Okay. Be able to read the code. Topic 4 is C programming. I really don't have anything that's anyway. Okay, two things. Maybe first is storage classes. Okay, when you are given a few lines of code, basically they are either a main function with some subroutines, or just two functions, whichever. And you should know which variable is global variable, which variable is local variable. So, and which variable can be seen in which program or which function. Okay, so those defined outside of any function basically can be seen in all the functions that is the same file. Let's say we have a C, something dot C. For example, your that sheet, that 1 or 2, switch dot C. Okay, let's say we have it doesn't need to be main dot C. Switch dot C. If it's a main dot C, usually it contains the main function. Okay, so that's a switch dot C. And in the switch dot C, there are function 1, function 2, blah blah blah. Okay, and out of this function, at the very beginning of this C file, there will be some variables. Blah blah blah. It really depends on how you define it. If you see it, the very general form, let's say int I, okay. Define integer I, then this I will be seen in all the functions of this file. Okay, may not be seen in other files. It really depends. Okay, and those which is only defined in the function 1, in the body of function 1, inside the body of function 1 or function 2. Okay. That is definitely a local variable. Alright. I mean, it is normally defined as an INTI, which is defined inside the function, certain functions, and it can only be seen by that function. Okay. So, the other thing that you should know is function call. Okay, what is function call is let's say you have defined a function, and this function will be called in another function. Usually, in main functions, you will call lots of subroutines or functions. Right? In main, actually main, let's say void main bracket is also a function. Okay, so but usually in this function there are many sub-functions will be called. So when you call a function, you have to pass if this function takes input. So function can take input, can give output. Function can take no input, return no output. Right? Can take input with return no output. Can take no input, return output. So whatever. But if there is an input, then when you call it in the main function, for example, you have to pass the input parameters to the function. Okay, so when you pass to it, then you should know how the variables or how the input parameters will be updated or involved in the calculation in that function. And sometimes the function returns some value. Okay, that is the output. Then definitely we won't see the declaration void, right? So it will be, let's say, int function 1. So it will return let's say a scalar or a function, a scalar or array. If it returns array, usually it will invoke a pointer. Okay, so the simplest way is to return a scalar. So you will see maybe in the last line of that function is line called result equals, and that result, whenever you want to use that result, you have to use result equal function 1. Okay, so or and there's another storage which is very special, is static. It is declared as static. So this one is different from others because the compiler will only initialize it once. Okay. So the other time, when compiler called the particular line, particular declaration line, you will just ignore the initialization. Okay. So, that's all for topic 4. Topic 5, serial communication. You can look at, there are a few questions actually used for, let's say, 7, question 7, question 8. Okay. So, it's also, there are also some similar things in the slide to transmit the data in the serial fashion. So basically, to transmit the data by serial port, the bits, the data bits, the data pack bits will be sent bit by bit. Okay, and there is certain protocol or rules to form a data pack. So we don't just send, for example, let's say an 8-bit data, ASCII character, just not S. We don't send just these 8 bits. it will consist of start bit followed by data bit. And sometimes it has parity check, right? So we have a parity bit and followed by the stop bit. So that the other side, which is for example, the receiver, okay, knows where to detect. And sometimes there are two stop beats, sometimes one stop beat. Basically, for start beat, it's only one beat. It will be given, I think, in the question. So what you need to know is follow the rules given and draw the waveform. Okay? And for example, you can see here. Let's set ASCII character capital S, which is text number 51. Okay, 5 is 0101, right? 1 is 0001. So before you set anything, the system is in the idle mode. So for idle is in logic 1. This start bit is always 0. Okay, start bit is always 0. Followed by, you should know this. Followed by, we will send which bit first after the start bit. Mostly significant bit or the least significant bit. We will send the least significant bit first. So and this side is LSB, and this side is NSB, right? So we actually will send 1 first, followed by 3 0, and then 1 0 1 0, 1 0 1 0. Okay, so when you read, it is actually 0 1 0 1 0 0 0 1, which is 5 1. Okay, when you send the 1 first, 0 0 0 1 0. And this is 8 bit. And last, you will follow by for this question 7. There's no parity bit. There's no parity check. So if there is a parity check, you should know whether it's an odd parity check or even parity check. Right? So if it's an even parity check, then if the data bits, the number of non-zero, the number of 1 bit if it's even, then this parity bit is set to 0. If it is odd, then this bit will be set to 1. Right? And if it's under odd parity check, if the total number of 1 bit is odd, then this bit will be 0. Okay? If the total number of 1 bit is even, then this bit will be set to 1. Okay. So for this case, for example, assume it is under odd parity check. Okay. So you can count how many odd bits. 1, 2, 3, 3. Sorry, how many 1 bit is odd number of 1 bit, right? So since it's odd number, so this bit is 0. Okay. So this parity is 0. And then the next one is stop bit. So assume there's only 1 stop bit. Okay, sometimes there are 2 stop bits. So it could be 1 or 2. And these 1, 1, 1, 1, etc. is idle. Means as we wait for the receiver to be ready to receive external devices and this is the logic value, okay? Logic 1 or 0. If you are required to draw it in a waveform, you should know. For logic 1, is basically respond to the negative voltage. Okay? It could be negative 3 volt, it could be negative 15 volt. So for example, my case is negative 15. Okay? So it's kind of small. Okay? So for logic 1 is negative. For logic 0 is positive voltage. okay, plus this voltage. Logic 1 is minus voltage. This is the requirement. So when you are asked to draw the waveform in voltage, okay, then the 1 you should draw minus 15, okay, for example. Then 0 is 1, sorry, 15, okay, 15. Positive 15, and followed by 1, again, negative 15, 3, 0, 3, positive 15, so on and so forth. Okay, and if I give you this waveform, are you able to draw for me what character I'm going to send?
Yes.
Yes, okay, so that's copy backwards over. So you can look at question 7 and question 9. Sorry, 7 and 8. And if, let's say for the database, sometimes, for this case, it's 8 bits, right? If 7 bits, for example, if you want to send this ASCII number S, which is 0, which is 01010001. So you will just truncate or throw away the most significant 0, which is actually doesn't affect the data, right? So of course you may argue, I can't send 111111 using just 7 bits, right? Yes, of course. But for this case, yes. Right. It doesn't matter, you can 4 bits. So the maximum number that you can send is 1111, which is F, right? And if it's 8 bits, the maximum number you can send is FF. Oh, okay. And if it's 8, sorry, if it's 7, the maximum number you can send is 111, 111. 111 is 7, right? 0, 111, 7, 7F. Okay, so this is number 6. I/O input systems. First is the it's very related to our lab. For example, in the lab, 1, 2, lab 2. You're using you're using cooling and interrupt driven for the I/O for the data transfer. So what are they and what's the advantage disadvantage? Okay. So when do you need to use cooling? When do you need to use interrupt? You can look at and the other one is preemptive and not preemptive scheduling. What are their advantage and disadvantage? Okay.